Hi, pre-calculus students. Welcome to section 3.4a. Excuse my hair. It's really clean, but it's big and a mess, and I really wanted to get the video done. So sorry about that. I can see my hair. Anyway, welcome to 3.4a. This is solving exponential equations. 3.4b would be solving logarithmic equations. So really nice short list of what we do. So here's how we solve exponential equations. We isolate the base, meaning if there's something multiplying a base or adding it, we do the opposite operation, the inverse, to remove that. We're going to take the natural log of both sides. Now, your book takes a different approach. It takes the log with the base of a base that you see. For instance, like a base of a fourth, right? Log base 1/4, log base 5, right? And but then you're making decisions, and math is hard enough, right? Taking the natural log of both sides of the equation works for everything, and it makes, when you have a base of e, which is super common, it makes it super easy because the natural log of e is 1. So no choices, and it really turns out nice. Take the natural log of both sides. We're then, because we have a logarithm, we will be able to apply the power property and bring our exponent out front and multiply it. Notice that those are exponents, right? Those are x's, and now we can solve for them. We are then going to do just basic algebra and solve for the variable, and we are going to check our solutions. I mean that on this video, just because, but to save time so it's not so long, but you would definitely check your answers. And we're just going to make sure that if it's a decimal answer, that we are going to round that to the third place, to the thousands place. So let's take a look. We have 1/4 to the x power equals 64. We actually could do this without a calculator or without taking the natural log of both sides. But again, the reason why I like solving exponential equations by taking the natural log of both sides, is it works for every situation. Whether you can do it by hand or not, whatever the base is, it works for everything. So let's do that. I'm going to take the natural log of both sides. There we go. This allows me to, because I have a logarithm, use the power property. I'm going to bring the x out front and multiply it by the natural log of 1/4. I could, in my calculator, get the natural log of 1/4 and the natural log of 64 now, but I like to gather the logarithms together because sometimes you're dealing with some difficult decimals, and if you do them, gather them, then you're doing it all at one time. And sometimes those difficult decimals actually come out to a really nice answer when you group them. So I'm going to take the divide by the natural log of 1/4 on both sides, right? And my x then will equal, coming down here, can you see that? Just making sure. Okay, so the natural log is 64. I'm going to use an alpha y equals, the natural log is 64 divided by the natural log of 1/4, comes out to a beautiful -3, right? So -3. And of course, if we checked it, we would find that that is a true answer. Number 20, isolate the base. It already is. Let's take the natural log of both sides. There we go. That allows us, by the power property, to bring the x out front and multiply it. And the natural log of e is 1. So we just have x on the left, and on the right, the natural log of 4, 1.386. If I took the time to put 1.386 as the exponent, e to that, it would be really close to 4, little off due to rounding. Take a look. We have a base of e isolated on each side. Let's take the natural log of both sides. We'll bring both of those exponents out front and multiply them by the natural log of e on both sides, so these cancel. So really, I'm just solving 2x equals x squared minus 8. This looks quadratic to me. I'm going to subtract a 2x from both sides. And I get 0 equals x squared minus 2x and minus 8. Okay, let's see if it's factorable. Two numbers that multiplied in negative 8 and add to a negative 2 would be x minus 4x plus 2. Yeah. And so our zeros would be x equals 4 and x equals negative 2. If you put either of these answers, 4 here and here, you would get the left-hand side equal to the right-hand side. If you put in a negative 2 here or here, it would be equal also. Okay, let's go over to number 34. On number 34, we need to isolate the base, right? It is being multiplied by 2. So we're going to divide both sides by 2. And we get 5x, 5 to the x equals 16. Let's take the natural log of both sides. That allows us to bring the x out front and multiply it. And we have x times the natural log of 5 equals the natural log of 16. There you go. To get the x alone, I'm going to divide both sides by the natural log of 5. I'll be sure, and my x will equal. I'll be sure to use an ND, numerator, denominator on my calculator, or use parentheses carefully, right? So the natural log of 16 divided by the natural log of 5. 1.723. With rounding. There we go. And again, if it was your homework, you would check it, right? Okay, example 118a. We are going to use the formula A equals P e to the RT like we did in section 3.1, because this problem does say continuous compounding. So you will also, if I gave problems like number 117 or 118, you will use this formula in that section. In fact, let's take a look. Oh, I closed the book. Sorry, it's 117. I think there's 4 problems, maybe 117 to 119. Okay, you would use this formula here. Okay, so there's a $2,500 deposit. We learned that that is our principal amount. There is a rate that is being paid on the deposit of 0.045, which is 4.5%. So we'll put that in for our R. And what they want to know is, what is the time right here that's required to double your money? Okay, so let's talk about this. We have our P is 2,500, E, and our R is 0.045 in T. Now, I am missing the T. I can't be missing the A. That's okay. I know what the A is. If we are looking for the time it takes to double your money, we deposited 2,500. So we are looking for $5,000 is an output amount. Here we go. To solve, right? We're trying to solve for this exponent. We're trying to solve this exponential equation. We have to isolate the base. It is being multiplied by 2,500. So let's divide both sides by 2,500. Of course, I'm going to get a 2 on the left, right? Because it was double. There we go. I have 2 equals e to the 0.045t. I will take the natural log of both sides. This allows me to bring the exponent out front and multiply it in front of the natural log of e. And the natural log of e is 1. So I have 0.045t. So all I need to do now to solve for the time is divide both sides by 0.045. There we go. And our time, this will be in years, will be the natural log of 2 divided by 0.045. That will take 15.403 years. It will take for you to double your money when your interest rate is 4.5%. There we go. So remember, when you're solving exponential equations, isolate the base, take the natural log of both sides, use the power property, solve for the variable, and check your solutions. So kind of a nice blast from the past. Have a great day.